Right. So today we're going deep on something pretty interesting, I think, visually.
Okay.
It's a flower
Mm-hmm.
called the fan flower,
Oh, okay.
or Scaevola aemula,
Mm-hmm.
if you want to get all fancy about it.
Right.
But so basically what we're looking at is this flower that's a little bit, well, weird looking.
Okay.
And we're going to be looking at a blog post
Right.
by a guy named Ang.
Oh, yeah. Aang. I took a look at his website.
Oh, yeah.
kianmn.org.
Yeah, yeah.
And it seems like this guy's got like a really curious mind.
Yeah.
He's a software engineer by trade,
Right.
but also into gardening photography, all sorts of things. Clearly likes to figure things out.
Definitely. Yeah, and that's what's so cool about his post on the fan flower.
Mm-hmm.
He starts off by saying he wasn't initially drawn to it.
Oh, really?
Yeah, he found it
Oh.
kind of unappealing.
Okay.
And honestly, I get it.
Yeah.
So picture this, you've got this flower, and the petals are arranged in a semicircle.
Oh, wow.
Like somebody took scissors and chopped the petals in half.
Uh-huh. Okay.
And they grow in these clusters along the stem.
Huh.
So it's not a subtle thing.
Right. Yeah, not your typical symmetrical flower.
No, not at all.
That's for sure.
But Ang, being Ang, he doesn't just stop at, that's a weird flower.
He goes deeper.
He goes deeper. He's thinking like a software engineer about it.
Mm-hmm.
You know, why this design? What problem is it solving?
Right.
And that's where this idea of adaptation comes in.
Adaptation. Okay.
Yeah. You know, nature doesn't just do things, just for kicks.
Yeah.
This weird semicircle shape. This
Yeah.
has got to have a reason.
Yeah.
Right. It's a product of millions of years of evolution. Which is basically nature's way of running this massive experiment in what works best.
Exactly. And when we talk about evolution, we're talking about these tiny changes in a plant that happen over generations.
Right.
And if those changes help it to survive better, maybe attract more pollinators, maybe spread seeds further, then they get passed on. So with the fan flower, we're looking at a shape that's not just random.
Yeah.
It's very likely a solution.
A solution to a problem.
Yeah.
Okay, so this is where I need like some expert brain power here.
Okay.
What are some of the ways that a shape like that could actually be an advantage for the fan flower?
Well, think about how pollinators approach a flower.
Okay.
Maybe that asymmetrical shape
Right.
makes it easier for a certain type of insect to land and do its job.
Interesting.
Or maybe it's about wind dispersal of seeds.
Okay.
We don't know for sure based on this blog post, but it's a puzzle we can look for clues in.
Right. Yeah, that's fascinating. So the shape isn't just about looks.
Right.
It's potentially about function.
Yeah.
It's like the fan flower is a lesson in itself.
Mm-hmm.
Don't dismiss something just because it looks different.
Oh, no.
There might be some serious smarts hidden in that design.
Yeah. And that's where Aang's initial reaction is so interesting. Like you said, he's a tech guy, used to clean lines, efficient code.
Mm-hmm.
And then nature throws him this curveball, a flower that's unappealing at first glance,
Right.
but actually might be like this masterpiece of efficient design.
Right.
Makes you think, doesn't it?
Yeah, it really does.
Yeah, it really does make you think.
It does. It really does.
And, it reminds me of something else Aang said in his post about, like, always learning, being curious.
Right.
It's like the fan flower itself is a lesson
Yeah.
in looking closer, asking why,
Right.
instead of just accepting things at face value.
Yeah, it's easy to get stuck in our own ideas about what's normal or beautiful.
Right.
And then nature comes along, shakes things up,
Totally.
shows us that there's other ways to be successful, other ways to be beautiful.
Yeah, absolutely. And, that ties into this whole idea of biomimicry.
Oh, yeah, biomimicry.
Which is basically using nature's designs as inspiration for our own technology and solutions.
Right, right. And we've already seen some amazing examples of that.
Oh, yeah.
Like how the shape of a kingfisher's beak helped engineers design high-speed trains.
Oh, wow.
That are quieter and more aerodynamic.
Huh. Interesting.
Or how the structure of a gecko's foot inspired the development of super strong adhesives.
Right, like those things you can stick on the wall.
Exactly.
Yeah.
It's incredible what we can learn from nature if we just pay attention.
Yeah, totally. And that brings us back to the fan flower.
Okay.
We've talked about its unique shape,
Right.
how it might be an adaptation for pollination or seed dispersal. But what if there's even more to it?
Okay.
What if that seemingly imperfect form
Yeah.
actually holds clues for solving problems in our own world?
Okay, now you've got me really curious.
All right.
How could something like a fan flower inspire human design?
Well, let's go back to thinking like an engineer for a second. Nature rarely wastes energy or resources.
Right.
Every adaptation, even something as seemingly random as a flower's shape,
Yeah.
often serves a purpose. So what if the fan flower's semicircular arrangement of petals
Right.
optimizes its exposure to sunlight for photosynthesis?
Oh, that's interesting.
Right.
So we could potentially learn how to build structures that maximize natural light and energy efficiency
Exactly.
based on the fan flower's design.
Yeah, or what if its shape, creates a specific kind of airflow
Okay.
that helps with pollination or seed dispersal?
Right.
Could we design more efficient fans or turbines based
Yeah.
on those principles?
That's fascinating.
It's all about understanding the why behind the shape,
Right.
the underlying principles that make it so successful.
It's almost like nature is this giant library of brilliant solutions,
It is.
just waiting for us to discover them.
I love that.
And the fan flower is like a book we're just starting to open.
Yeah, it really captures the essence of biomimicry.
Mm-hmm.
It's not just about technology or engineering. It's
Right.
about a shift in perspective.
Yeah.
It's about recognizing that nature is not just something beautiful to look at. It's also a brilliant teacher.
It really is. Okay, so for our listener out there,
Mm-hmm.
what's the takeaway message here?
Mm.
Why should they care about the fan flower and this whole idea of biomimicry? I mean, it's like you said earlier, the fan flower is kind of a wake-up call.
Yeah.
You know, we get so used to like our human way of doing things,
Mm-hmm.
we forget that nature has been solving problems for millions of years longer than we have.
Exactly. And often nature's solutions are way more elegant,
Right.
more efficient,
Yeah,
and definitely more sustainable than anything we could come up with.
for sure.
The fan flower is the perfect example.
Yeah,
Its shape might seem odd to us humans,
yeah.
but it's clearly working for the plant,
So if we could really understand the science behind that shape,
right?
like the hows and the whys of its adaptation, we might unlock some seriously cool innovations.
Yeah.
Imagine creating buildings that naturally ventilate,
Oh, wow.
like a fan flower,
That'd be amazing.
or designing solar panels that maximize energy capture based on its structure.
Yeah, I mean, it's not just about copying the shape, though. It's about
Mhm.
understanding the principles behind it.
Right. The why.
Yeah, like what are the forces at play?
Mm-hmm.
How does the shape interact with its environment?
Right.
Once we understand those principles,
Yeah.
then we can apply them to all sorts of challenges.
It's like learning a new language almost.
It
The
is.
language of nature's design.
Yeah, once you know that language,
Right.
you can start to see the world in a whole new way.
Yeah.
Suddenly, everything becomes a potential source of inspiration.
Yeah. That's amazing. And that's the beauty of biomimicry.
It is.
It's not just about technology or engineering.
Right.
It's about a shift in perspective.
Exactly.
It's about recognizing that nature is not just something beautiful to look at. It's also a brilliant teacher.
The best.
Yeah. So for our listener out there,
Okay.
next time you see something in nature that seems weird or unusual, don't just dismiss it.
Right.
Take a moment and ask yourself, why is it like that?
Yeah, what?
There might be a hidden lesson there,
For sure.
a brilliant solution just waiting to be discovered.
Absolutely. And who knows?
Yeah.
Maybe that little spark of curiosity will lead you to create something amazing. The world needs more people who can think like nature, who can see the beauty and the brilliance in the unexpected.
I love that. Well said. That wraps up our deep dive into the fascinating world of the fan flower,
It was fun.
the power of biomimicry. We hope you've enjoyed this journey with us,
Yes.
and that you'll join us next time for another deep dive into the depths of knowledge.